Our worst case scenario is basically trying to take all the fans in the house, anything that vents outside, and anything that forces air, and using that to try to depressurize the house as much as we can. So what we're doing is we're taking a baseline reading from our combustion appliance zone, which is going to be over here where our two furnaces are. Here is going to be one combustion appliance zone, and then the attic would be another one. So we're going to create a worst case scenario, trying to depressurize those rooms as much as possible to make them backdraft if we can. So there's different venting configurations, and each venting configuration has a limit for depressurization. So let's take, if you take an Orphan hot water heater, has a limit of -2, I believe, and so basically your pressure between your combustion appliance zone and your outside, say it's 1.1. After we put the house in worst case scenario, which means we're going to turn on all the bath fans, the range hood if it vents outside, turn on the fans for the house through the HVAC system, anything that vents outside or is forcing air. Then we're going to test under each room, and if it's positive pressure, which means air is being forced out towards us, we're going to keep the room closed. If it's negative pressure, which means it's drawing air towards it, we're going to leave the door open. So again, we're creating that depressurization. So then we'd do that for every room, starting at the farthest from the combustion appliance zone, work our way back. Last one we're testing is the door to the combustion appliance zone. And then we're going to take another pressure reading. So we had, what I say, 1.1 to start. So if our pressure after we do all this worst case, if it was negative 0.9, would be the depressurization limit would be -2. So then that combustion appliance zone would fail. If it fails, then you have to take certain measures like providing makeup air towards the combustion appliance zone, which would bring outside air in for combustion. There's makeup air units is what Minnick does a lot of times. If a combustion appliance zone is small and we have a large amount of BTUs that we're trying to fire in that area, then we'll have an air handler with a damper system that feeds that room, that combustion appliance zone. It's bringing air from outside and feeding it to that room when it's needed, when the combustion appliance is firing. That would be the best case. Worst case scenario, you'd have to cut holes in the wall or in the doors to create a transfer grill, which is going to allow more free space for combustion. We like to control it. We'd like it to be something where you can draw air when you need it and shut it off when you don't need it. That would be the best case scenario. Worst case scenario, like I said, is just cutting a hole and allowing air to come and go as it needs to.